Okay, so we're going to go ahead and discuss the very first section in chapter 1, tables and graphs of linear equations. And our objective here is we're going to represent real-world linear relationships in a table or graph or equation. So we're going to do one problem in which we do all of these different items. The idea here is this is a review piece, but it just shows how we can take something that's a real-world or slightly real-world application and use all these different things to look at the information and see what's happening with the numbers. Okay, so here's the problem. It's a physics problem, and states here that acceleration is the rate at which the velocity of an object changes. Now, granted, this is most likely not going to be a linear relationship. The problem's change, so we can work with it as a linear relationship. And we want to suppose that an airplane is traveling in a straight line at a speed of 60 meters per second, and the plane then accelerates and its speed's increasing at a constant rate. So one of the biggest things here, this key word, the vocab is what sometimes causes issues. People don't really understand what's being asked sometimes, and this key word, constant rate, means that we're working with a linear relationship. And the constant rate is at 0.5 meters per second. So these are the 4 different things that we're going to do. Make a table based on 1, 2, 3, and 4 seconds. We're going to graph the points represented by the table, and we're going to write a linear equation relating the speed of the airplane, which is v. Okay, so we want to make sure that we're using the variable that's associated in the problem to the number of seconds t of constant acceleration. So after a certain amount of time, the velocity is going to be at a specific rate. And then finally, we want to know what the speed of the airplane is after 15 seconds. So once we find our function or the equation, we can then determine what the speed is going to be at any given time. Okay, so here's the problem restated, and what we're going to do here is we're going to go ahead and make a table for the speed of the airplane at 1, 2, 3, and 4 seconds. So if it's constant, if it's accelerating at 0.5 meters per second, it starts at 60, so at 1 second, our rate of speed is going to be 60.5. So if we're going to make a table, it's going to be horizontal, vertical, doesn't matter. What I'm going to do is I'm going to have 2 columns. Okay, and what I'm going to do here is I'm going to call this time. I'm going to call this velocity. And after 1 second, we know we start at 60 meters per second, or that's when we start calculating the change. I just keep on adding the half of a meter per second. So at 2 seconds, we'd be at 61. At 3 seconds, we'd be at 61.5. And let me erase this a little bit here. I ran out of room. And at 4 seconds, I'd be at 62. That's it. That's a table that shows the relationship. And one thing that we can look at here is the fact that as my time changes, it changes at a constant of +1. This changes at a constant of 0.5. Okay, so what we're seeing here is a constant rate of change between our x's and our y's. And what that tells us is we're dealing with a linear relationship. Okay, so now, acceleration is the rate, right, so on and so forth. We want to graph these points represented by our table. Let me go ahead and erase what I have here. We'll just leave that there, not a big deal. So we're going to graph the points that were represented by our table. So we had points were, let's put our table here. I'm going to rewrite this real quick. We had time and velocity of 1 was 60.5, 61 for 2, 3 was 61.5, and 4 was 62. So really all I have is these points, a 1, 60.5. where t is the same as x and v is the same as y. So we're going to go ahead and graph this. Okay, so we got our graph here, and this axis right here is our y-axis, which is velocity. So we'll mark this with a V. This axis right here is time, so we'll mark this with a T. And the one thing that we can do here is we have 60 units, 61, 61.5, so on and so forth, and we have 1, 2, 3, 4, so on and so forth. As long as I'm consistent with my scale, it doesn't matter. So what I mean by that is every 2 units I'm marking a hash mark, and so that will be my seconds. Okay? And I can do the same here, or I can do every 3 units, or it doesn't really matter. I just want to work within the space. So I have 14 units up and down. I can basically say that this right here is 60. Okay? And I can do 60.5, 61, 61.5, and 62. A little messy, apologize, but gets the point across. Now I'm going to plot my points. At 3, we were at 61.5. Oops. Let me erase that. At 1 second. We were at 60.5. At 2 seconds, we were at 61. 3 seconds, we were at 61.5. And at 4 seconds, we were at 62. And you'll notice here, this point, which is our y-intercept, and that gets us our line. Okay, so we plotted the points, drew the line, we see the linear relationship. And write a linear equation relating the speed of the airplane, velocity, the number of seconds t of constant acceleration. So we know when time is equal to 0, we know velocity is equal to 60. Because time is 0, this is our y-intercept. Okay? We know that the constant rate of change, which is our slope, is 0.5 meters. And we have an equation which is y is equal to mx plus b, where m is our slope, b is our y-intercept, but really we're dealing with velocity is equal to a constant rate times time plus the starting speed. So my velocity is equal to 0.5 t plus 60. There's my equation. Now, what's the speed of the airplane after 15 seconds? Well, I have my function that I've created, and I know that that's v is equal to 0.5 t plus 60. So after 15 seconds, we can pull out our calculator, or we can know that 5 times 15 is 75, move the decimal over, and add 7.5 and 60, and our velocity is going to be 67.5. Last but not least, a couple of graphing examples. We're actually just going to do the first one here. Actually, no, scratch that. We're going to look at all 3 of these to a certain extent. And what I just want to do here, because this is review, this is B, or the y-intercept. Okay? And this guy right here is our slope, which is rise over run. Okay? This is the most important thing. And when we have a negative slope, we know that we're decreasing from left to right. When we have a positive slope, we're increasing from left to right. So why don't we just go ahead and graph this guy right here. We know our y-intercept is -5, so I'm going to plot a point at -5. And then I know my rise is 1, and my run is 3, rise over run. So I'm going to go up 1, and then over 3, 1, 2, 3. That's my next point. Do the best I can to draw a straight line, and I've just graphed my function. So this is just a general video discussing linear relationships, graphing lines, using tables, and looking at constant relationships.